MS Ramaiah University of Applied Sciences.
Hello students. In this video we will be discussing the computer aided manufacturing CAM using Capsmill simulation software. The learning objective of machine shop simulation lab through Capsmill software are to provide experience on modeling, generation of tool path and part program through Capsmill software, to identify the sequence of operations, to select the cutting tools, cutting parameters and work holding devices for various types of milling operations, demonstrate the different types of operations through graphical simulation, to generate the GN codes, time study sheet, tool list and tool layout sheet for the existing model. Capsmill is a software that allows users to create GN code programs that can be used to cut different geometric shapes on CNC milling machines. Capsmill software includes a CAD environment, a geometry to G-code translator, and a G-code simulator. It is support to learning CNC technology, understanding machine operations, selection of cutting tools and cutting parameters, usage of work hold devices. It helps to learning and practicing machine operations safely and economically without damage to the machine or injury to the students or the operators. The Capsmill software is supported to user with following steps: creating the part and blank shapes, performing machining operations, viewing the tool path, generating NC program, generating documents. Experimental model. Students see the part drawing for the machining operations like face milling, pocket milling, slot milling, drilling, and counter boring using Capsmill simulation software. Experimental procedure. The Capsmill programming process consists of the following 8 steps: start new program file, define work setup, draw the part, define blank, perform machining operations, select machine, simulation, that is view tool path, generate NC program, power, tool list and time study list. Define work setup. Start Capsmill. Double-click on the Capsmill icon. The work setup dialog box appears automatically when you start a new part. In the start data, enter the following. Units are in mm. Select the work material, cast iron, alloy, medium hardness. Leave the clearance, Z 100. Enter the tool change position, X equal to 100, Y equal to 100, Z equal to 100. Click on the Table Setup tab and select the first radio button. Click on the Documentation tab and enter the graphical data as shown below. Part number 123, part name, block, setup number 1, fixture name FXT23, programmer name, username, save the file as block. Create blank. As per the part drawing, go to the main menu, select draw, shapes, rectangle and enter the dimension 200 x 200 mm and specify the center point x, y equal to 0, 0. Select define part, click OK. Create part. Go to the main menu, select draw, shapes, polygon and enter the values in the dialog box that appears. Number of sides are 8 and length of side is 60 mm with 5 mm corner radius and specify the center point xy equal to 0, 0. Click OK. Draw another rectangle of dimension 60 x 60 mm and slot of size 60 mm long and 15 mm width and specify the center point x, y equal to 0, 0. Click OK. For creating the holes, go to the main menu, select Draw, Point Pattern, Points on Parallelogram and enter the following data in the dialog box. Length 150, width 150, number of holes along length 2, number of holes along width 2, included angle 90, angle of side 0. Specify the location point and enter the x and y equal to -75, -75. Click OK. Define blank. In the main menu, select Draw, define blank and click on Select Contour in the dialog box that appears and click on rectangle of 200 x 200 mm yellow color. Enter blank thickness as 55 mm and Z coordinate at the bottom as 0. Click on OK. Machining operations. Switch to the machining menu by clicking on the machining button on the dialog bar. Select machining, milling, face milling. Select a 40 mm diameter end mill. The tool is available in General MM Tool Library. Face milling operation. Select cutting method for facing operation in the same dialog box and enter the entry or exit distance of 5 mm and select cutting method by click on one way. Select the cutting parameters for roughing and finishing operations and enter the cutting speed, feed rate and depth of cut values or accept the default values. Select the machining data and enter the following. Work surface Z equal to 50, material thickness 5, allowance after roughing 0.3, return to Z 100. Click on OK. Select the contour for face milling, rectangle block of 200 x 200 mm and click a circle to specify the machining start point. Click on OK. Pocket milling operation. Click on machining, milling, pocket. Select a 20 mm dia end mill from the tool library for pocket milling operation. Select the octagon for pocket machining. At the prompt, do you want to specify islands? Select Yes. Click on the smaller rectangle. Now enter the following data. Operation name, mill pocket excluding islands, work surface Z equal to 50, pocket depth equal to 20, bottom allowance after roughing 0.3, click on cutting method tab and enter cutting method equal to zigzag. Click on cutting parameters tab and enter the depth of cut equal to 2. Click on OK. Slot milling operation. Select machining, milling, slot mill and click on new tool in the dialog box that appears. Select a 12 mm dia end mill for slot mill operation and enter the following. Operation name, slot milling, process, rough and side finish, work surface Z equal to 50 mm, slot depth equal to 10 mm, bottom allowance after roughing equal to 0.3, return to Z equal to 100. Click on tool entry or exit tab. Entry distance equal to 10 mm, exit distance equal to 10 mm. Click on OK and save the file. Spot drilling operation. Select 8 mm dia center bit from the list in the tool library and specify the 4 points on parallelogram for drilling operation. Enter the following data for spot drilling operation. Work surface Z equal to 50, hole depth equal to spot 4 mm, return to Z equal to 100. Drilling operation. Similarly, select 8 mm dia drill bit for through hole drilling from the tool library. Select 4 points on parallelogram for drilling operation and enter the following. work surface Z equal to 50, hole depth equal to 55 mm, return to Z equal to 100. Counter boring operation. Select 13 mm dia end mill for counter bore from the tool library and specify the 4 points on parallelogram for drilling operation. Enter the following data for counter boring operation. Work surface Z equal to 50, hole depth equal to 10, return to Z equal to 100. Machine tool. Sequence of operations are simulated through FANUC 6M machine. Tool path simulation. Select tool path for simulation of the model through order wise. Simulation starts in solid mode and C in isometric view. Simulation can be till the next motion, next tool, next operation or end of the program. Now see the simulation video. Generate NC program. Click on NC program on the menu bar and see the generated NC program. Power graph. Click on Documents in the main menu. Select Power graph. A graph indicating the power consumed for each operation is displayed. Click on Close to exit Power graph. Tool list. Click on Documents in the main menu. Select Tool list. See the list of tools used for the process. Click on Close to exit from the tool list sheet. Cycle time list. Click on Documents, Tool layout sheet. See the cycle time list for the selected cutting parameters and cutting time. See the total machining time. Click on Close to exit from the tool layout sheet.
At MSR UAS, we spark your imagination unlike any other.